The next astronauts who walk on the moon won't land in a government-built spacecraft. They'll step out of a vehicle designed, built, and owned by a private company, either SpaceX or Blue Origin. NASA is betting billions that the competition between Elon Musk and Jeff Bezos will get America back to the lunar surface faster than any government program ever could. But that bet comes with real risk, because the Artemis campaign is already years behind schedule, and everything now hinges on whether this commercial model actually delivers. Apollo was vertically integrated. NASA designed it, NASA built it, and NASA owned every piece of the stack. Artemis is fundamentally different, and we need to understand why that matters. NASA still provides the mission architecture, the Space Launch System, the Orion capsule, and the Gateway lunar station. But the lander is outsourced. The Human Landing System, or HLS, is being developed by commercial partners under fixed-price contracts, and the logic behind that decision is to leverage private sector innovation, share development risk, shorten timelines, and reduce long-term cost. So, this is the best of all worlds. Consider what the alternative looked like. The Apollo program, adjusted for inflation, cost roughly $280 billion over a decade. NASA cannot and will not spend that again. The commercial model exists because the math of government-only spaceflight no longer works. In a world where China is accelerating and congressional patience has limits, the idea is sound. What's less certain is whether it works in the environment where it's being tested, deep space, with human lives on the line, and a geopolitical competitor closing the gap. Simple on paper doesn't mean simple in orbit. NASA initially awarded the first HLS contract exclusively to SpaceX, which triggered an immediate protest from Blue Origin. Congress got involved, and ultimately, NASA funded a second provider, Blue Origin, to ensure program redundancy. This was a deliberate strategic choice, and it actually makes sense. You see, two vendors mean competition drives innovation. A single failure doesn't halt the entire campaign, and NASA avoids the dangerous trap of single-provider dependency. We saw what single-provider dependency looks like with the space shuttle. When it grounded, America lost access to orbit for years. NASA isn't making that mistake again. There's also a deeper strategic dimension here that doesn't get enough attention. When two American companies are racing each other to perfect a lunar lander, the pace of development accelerates in ways that a sole-source contract simply cannot replicate. Every time SpaceX solves a problem, Blue Origin has to respond. Every time Blue Origin demonstrates reliability, SpaceX has to match it. That internal competition is itself a national asset, and it's one that China's centrally planned space program cannot manufacture. But there are real costs to running parallel development paths. Resources get divided, complexity increases in the near term, and coordinating two very different engineering philosophies against the same mission timeline is harder than it sounds. Competition accelerates progress, but it also raises the stakes for everyone involved. Before we go in detail about this project, make sure to subscribe to never miss out on similar exciting updates on the space race. SpaceX is building its HLS variant directly off Starship, a reusable Super Heavy launch system that Elon Musk has been developing for nearly a decade with an eye on Mars, not just the Moon. The upside of that approach is enormous. If Starship works as planned, it doesn't just enable lunar landings, it unlocks the entire Mars architecture that NASA needs for the next generation of deep space exploration. The core engineering challenge is orbital refueling. Starship can't carry enough propellant to reach the Moon in a single launch, which means SpaceX must launch a tanker variant into low Earth orbit and transfer hundreds of tons of cryogenic methane and oxygen between two ships in microgravity at 17,000 miles per hour. That demonstration is targeted for mid-2026, and no company in history has done it at this scale. If the transfer fails, the crewed landing timeline collapses entirely. Speed is SpaceX's defining advantage. Rapid manufacturing iteration, reusability, and Musk's willingness to accept failure as part of the development process have compressed timelines that would take traditional programs decades to complete. The risk is integration. Starship is technically complex, still in aggressive development, and dependent on multiple breakthrough technologies that must work seamlessly together. And we should be clear about what the stakes of integration failure actually mean here. This isn't a robotic mission where a tipped lander costs us science data. When Starship carries astronauts to the lunar surface, every system has to work. The orbital refueling, the descent engine, the landing legs. One failure in that sequence doesn't end a mission, it ends lives. That's the weight sitting behind every engineering decision Elon Musk's teams are making right now. Jeff Bezos is taking a different route. Blue Origin's lander, Blue Moon, leans on heritage propulsion development, a national team of established aerospace contractors, and a modular architecture designed for incremental improvement rather than dramatic leaps. The strength of that approach lies in its stability. Blue Origin works with institutional partners who carry political backing and deep manufacturing experience. Their BE-7 engine has been in development for years, and the step-by-step methodology they've adopted gives NASA confidence in predictable progress. The Blue Moon Mark I, scheduled for its first lunar mission in early 2026, is designed to stay operational for months and carry 3 metric tons to the surface, roughly 30 times the payload capacity of the small CLPS landers we've been flying so far. The risk is pacing. Blue Origin has historically moved more deliberately than SpaceX, and in a campaign that is already years behind schedule, the cost of deliberate is measured in time we may not have. China's lunar program doesn't wait for committee reviews, and every month of delay is a month of ground lost. Artemis was never just about putting boots on the moon again. The stated goal is sustained presence, a permanent, repeatable human foothold on the lunar surface that serves as the foundation for everything that comes after, including Mars. That requires a lander we can fly repeatedly. The first successful HLS demonstration won't just be a milestone for the mission. It will be the moment the entire campaign shifts from aspiration to infrastructure. Once humans descend to the lunar South Pole, supply chains form, surface systems expand, and commercial payloads begin flowing in ways that self-sustain the program. We stop depending entirely on congressional budget cycles and start building something that has its own economic momentum. But if HLS slips significantly, the entire Artemis timeline stretches with it. International competitors gain the narrative leverage they've been waiting for, and the political will to keep funding the program comes under real pressure. NASA Administrator Jared Isaacman put it plainly on February 27, 2026, when he restructured the program. With credible competition from our greatest geopolitical adversary increasing by the day, we need to move faster, eliminate delays, and achieve our objectives. The crewed landing has moved from Artemis 3 to Artemis 4, with 2028 as the new target. Every delay has a cost, and that cost is now being measured against China's timeline. NASA's Commercial Crew Program proved the model works in low Earth orbit. SpaceX now routinely transports astronauts to the International Space Station, on time, at a fraction of the cost of the shuttle program. That track record gave NASA the confidence to apply the same logic to deep space. But HLS is categorically more demanding than a Crew Dragon docking at the ISS. It requires deep space navigation, lunar descent, and ascent under conditions we can't fully simulate on Earth, and surface survival in an environment that kills unprotected hardware within weeks. The upside of commercial contracting is real. Fixed-price incentives force efficiency, innovation moves faster without the government procurement bureaucracy, and private capital leverages taxpayer dollars more effectively than a traditional cost-plus contract ever could. The downside is equally real. NASA has less centralized control over engineering decisions. The program is exposed to the financial health of private companies. And execution variability, the gap between what a vendor promises and what they deliver, is higher when the government isn't overseeing every design choice. If the model works, Artemis accelerates the development of a self-sustaining lunar economy. If it falters, NASA absorbs the political consequences of a program that handed America's return to the moon to companies that couldn't execute. At the center of this rivalry are two of the wealthiest people on Earth, both of whom have staked significant personal credibility on their lunar ambitions. Elon Musk has built SpaceX into the most capable launch provider in history. Jeff Bezos founded Blue Origin specifically because he believes humanity's future is in space and has funded it out of pocket for over 2 decades while waiting for this moment. But beyond the personalities, we're watching something unprecedented take shape. For the first time in history, the hardware that returns humans to another world may be owned and operated by private corporations, not governments. The implications of that extend far beyond who wins a NASA contract. Whoever builds the reliable lunar lander and proves the model works at scale sets the template for every deep space mission that follows. Mars, the asteroids, whatever comes after. This competition isn't just about the moon. It's about who writes the rules for the next century of human spaceflight. The question we should be asking isn't who wins the contract. It's whether this model works at the scale it needs to. If SpaceX and Blue Origin deliver reliable, reusable lunar landers, NASA's commercial strategy becomes the blueprint for Mars and every destination beyond. The commercial moon becomes the proof of concept that justifies the entire approach. But if development delays compound, if integration issues stack up, if the orbital refueling test fails and the timeline slips another 2 years, critics will have the ammunition to argue for a return to centralized government design, and the political window for Artemis may close before it ever fully opens. Artemis depends on this rivalry, not as a backup plan, but as the core of its architecture. Because in this phase of the lunar race, competition isn't optional, it's structural, and the success or failure of the human landing system will determine whether America's return to the moon becomes the foundation of something permanent, or just another chapter in a program that promised more than it delivered. We've spent 50 years looking at the moon. The question now is whether we've finally built the model that lets us stay there.